Okay, so now let's calculate the probability that z will be between two values. So again, this is for a normal probability distribution and specifically a standard normal distribution. So this means the mean is equal to 0 and the standard deviation is equal to 1. So let's say we want to calculate, the probability that the value is between negative 0.5 and positive 1.25. So again, let's draw our distribution. We have mean of 0. So we want it to be between negative 0.5, right? So it comes below 0, and then positive 1.25. So that's up here. And we want the area between this curve, or between these two lines here, right? These two values. So we want the area under this curve, under this section right here. So what we can do is we can actually calculate the probability of all this area from here down, and then we can calculate the probability of this area down, and we can actually subtract this area right from this entire area, because that would leave us the leftover dark shaded blue area. So let me say that again. If you want to find the area, right, or the probability between two values, you can take your larger value and calculate the probability of this entire area, and then subtract from that the area of your lower bound, right? Because if you found the probability up to here, you could just subtract that, and then your leftover would be this area in between. So let's do that. We're going to calculate the probability that z is less than or equal to 1.25, and then we're going to calculate the probability of it being less than negative 0.50, and then we're going to subtract this value, the second one, from the former. So it looks like this in Excel, but let's go to Excel and do that together. So again, our function is norm.s.distribution, because we're working with the standard normal, and we want 1.25, that's our first one, and true, because we want the cumulative, we want the whole area right below 1.25, right? And then we want to do this again, but for negative 0.50, and again true, and we come up with these two values. But remember, we want to subtract from our first one, the big one, we want to subtract that second value, right? And then that's what we're going to end up with. We're going to end up with 0.5858, which is our answer here. So again, I hope that makes sense, right? We're taking the area up into here to 1.25, and then the area up until 0.50, and we're going to subtract off this little tail from this whole area to be left with this area in between. So basically, the probability that z would be between negative 0.5 and 1.25 is about 59.59 or 59% chance. Let's look at the third one, or I think we're going on a roll here. So let's say that the probability that z will be greater than or equal to a value. So now we want this tail part up here. So remember, the area under the entire curve is equal to 1. So what we could do is we could find the probability up until this value here, right? We could find this whole light shaded area and just subtract it from 1, and we'd be left over with this little region right here. So that's exactly what we can do. So let's assume that we're looking for that the probability that z will be greater than or equal to 1.58. So let's go to Excel and let's calculate that. So again, equals norm.s.distribution, 1.58, cumulative equals true. We get 0.94. And remember, we're going to subtract that from 1 to get that tiny little leftover area right there. And this makes sense too. Like, think about it conceptually when you do these problems. Does my solution make sense? So we know we're looking for a small area, this tiny little area here. We want to know, hey, what's the probability that z will be greater than or equal to at least 1.58 standard deviations above the mean, right? That's this little area right here. So it comes out to be 0.057, 0.057. And so that's it for calculating the different probabilities. The next video we're going to talk about calculating, doing the opposite, calculating the z value given the probability.